Hello, ladies and gentlemen, to another edition of practice session regarding my preparation to the CKAD Kubernetes certification. And today we'll be doing some Docker, which is the underlying technology upon which Kubernetes works. And we'll be doing some revision on working with images, Docker files, and building and running. So let's answer some of these practical questions. Now, how many images are available on this host? So this is how we get the number of images, Docker image, and we just count the number of lines here. And I can do that by piping in this to count the number of lines. We can see 10 here, but actually it's 9 because the 10th line is this header. So the rest of the lines is 9. So I'll take 9 images here. Now, what is the size of the Ubuntu image? If we observe very well, it's here. It's 77.8 megabytes. I'll pick it. Now, we just pulled a new image. What is the tag on the newly pulled image? Now, this is the tag column here. We can just, he said it pulled a new one, so I just rerun again Docker images, and which is new is this one is added there, which is the Nginx image. So the new tag is 1.14 Alpine. Now we just downloaded the code of an application. What is the base image? Inspect the Docker file inside this directory. So where are we? Let's just say ls. Okay, I can enter inside the directory, and let's redo ls, and we can see the Docker file. So I'll just display the content of that Docker file, and this is the content. I can display with -n so that we can get line numbers. Now what is the base image? This is the image from. Docker files always start with from, which is the base image upon which the container will be built. So from this image, so it's Python 3.6 here. To what location with the container, within the container, is the application code copied during a Docker build? So during the build, there is a copy that takes place at line 5. So the saying in what location is /opt. So I'll pick /opt here. When a container is created using the image built with this Docker file, this one, what is the command used to run the application inside? So when it will be built inside, this is the command used to run. You look at the entry point. That's the entry command upon which all of these will be run. It's Python app.py. It's basically a shell command that is put in the form of a list. So it's Python app.py here. Next question, what port is the application run within the container? Within the container is actually easy to see. This is the port upon which the container runs. The app runs inside the container. That's 8080. You can always see beside the expose command. So build an image using this Docker file and name that image this. So list again, this is my Docker file. I need to build an image regarding that. So I say Docker build, and I add a tag, which is the name that is going to be given to the image, which is web app color. And I say dot, which means take the Docker file from this current directory. It knows that it has to look for a file named Docker file actually. So I run. This is going to take some time regarding the size of the images, the time it takes to extract, and probably probably the network speed, actually the internet, if you wish. So download is complete. Now extracting one after the other. This is actually the Python library file has been extracted. So the many things that are being that were downloaded before. It's extracting one after another. It's already pulled the Python image. We're going to see as it's doing that, we're going to see this is going to take some time, so some patience. We're going to see all the steps. We have 6 steps going on, because if you look at the file here, these are 6 lines. So it's going to detail the steps as we progress, and you are going to see them live in the screen. So we are still on step 1, which is actually the heaviest because of all this download and extractions, and has to do with internet speed. After that, when all of that is extracted, all of this take place within the local machine, and it's going to be very, very, very fast. A little bit of patience. Right, it's done extracting, and step 2, we're doing some pip install. Let's just scroll up while it's doing that. So this is step 2 here, pip install Flask. I think I saw it somewhere here. That was fast. Actually, all of this, it has some more download to do. And then step 3, what step actually running now? Step 3, it was copy. That was fast. And then exposing to a port, and then changing a working directory here. That's step 5. And the last step is actually running this command. Here we have some warning, just warning, no errors, so we are still good to go. It has to do with pip versions. I think that should be because the lab was built a little bit some time ago, far behind. So this lab actually needs some update, but that's all. Okay, so we just built the image. So if I say Docker images again, we can see the web app color that's just got built 37 seconds ago. If I check, it's good. Next, run an instance of this image and publish on this pod, and publish this pod on the container to this pod on the host. How do we run images in Docker? It's Docker run, and we give the name of the image, which is called web app color, and then we can, let me remove this. And then Docker run, we expose the port. This is how we do it, -p for port. On this host is going to run on 8282, and that will be the same application that runs on the container at 8080. So let's run this, and it's actually running. We can actually consult it using this IP address if it's exposed, if it's a public IP. If not, I think the way Kodekloud, because I'm doing this lab on Kodekloud, the way Kodekloud usually configures test apps for you to test and see if they're running is usually included somewhere here. So this is the host at 8282. Let's just check, and we can see the app is running here. Okay, so I can just do a check here, and everything is fine. Next question. So I just accessed the application here using the root. That's why we see the get slash here. If I type something else like /tests, it's a URL that doesn't exist, but we can see. I think normally we're supposed to see it here. Yeah, we can see it here. It returns a 404 page. Now access the application by clicking on the host. That's what we just did here, and Control C if you want to stop this. Okay, well, let's allow it to run and stop if necessary. Now, what is the base operating system used by this Python image? So I'm going to Control C to stop all of this, and ls, and let's display this Docker file in display the line number. So this is an image. Like we said, every image is built upon, every image, project image and Docker is usually built from a base image. So the question is, this very base image, upon which other image is this Python 3.6 built upon? The only way to look at that is through the documentation, and since all of these were pulled from the internet, suppose it's in the Docker Hub. So let's open the Docker Hub. I can even search on it on Google. I just say Docker Hub Python 3.6, and this is it. And normally from the image documentation, we'll be able to see how it is built. This is all the list of commands that builds it. Let's look for details. Where does it start? From the beginning. This is the command to run it, so it should actually start up. Something's been downloaded here. I don't know what it is. We can see here from Debian. It actually built from Debian. This is the image hierarchy. Built from Debian, and then it starts adding all these other layers. So it's actually Debian here. Let's go back to the exercise and type Debian. Now, what is the approximate size of the web app image? Well, just type again that Docker images again and just grab the size here. It's about 900 megabytes, which is here 913. That's big. Docker images are supposed to be small and light. Now I'll try to trim it down. Okay, the easiest way to trim it down is if they are usually alternative to the base image use, because sometimes some images have other versions that are lighter. So it says build a new small Docker image by modifying the same Docker file, name it this and target this. Find a smaller base image of Python 3.6. Make sure the image is less than 150 megabytes. So let's go back to Docker Hub and let's look for a Python 3.6, a lighter one. It says let it be less than 150, which means that probably this one was heavier. And this is it. We can say this is actually 344 megabytes. If I look at I hope I can get the history when all this thing was building here. We can also see the size somewhere, especially when it was being downloaded or when it was being extracted. That was on step 1. This was downloading all of it, downloading Python 3.6. Oops, we can't see. I can't see the size there. Not bad, it doesn't matter. So what I was saying is here we can see that it's 340. Let's look for something that is lighter. Python. Let's just search for Python 3.6. Let's look for official images here. That will be easier for us. can see Python, nothing to be found. Let's go back to the initial one that we had here. This is Python here, 3.6. Let's go back to the library. This is a specific version. Let's go back to the whole library here. So this is the latest version. Let's look for a 3.6, a light one. This is 3.9. I can filter tags here. So let's look for 3.6. Yeah, so I have 3.6. This is a very light one. Slim Buster, Slim Bull Eye. This is lighter too. So we can take any of these two actually. This is a heavy one, 300. So let's take Slim. This is 3.6. The official one, the one that we actually have now, 333, because it's just 3.6 as a tag. No, it was 3. I think it was 3. Yes, 3.6. That's it. So let's look for something like this. Is another 3.6 super light, 14 megabytes. Let's take this one, 3.6 Alpine. So let's go back to the exercise, and I'm going to edit that file and change the name of the version, the name of the tag if you wish, 3.6 Alpine. So I'm going to save and create. I just did that, and now let's rebuild this image, and it says target web app color and target light. Let's say light like this. This should be quite fast because that's a very light image. It was even fast, we couldn't even see the download. So all of it's done, extracting, collecting. Let's wait for it to finish. Now it's done. So let's check if our images are there. All what is red here is just warning, so no need to panic. This is our light one here, web app light. We can see the new size is 51 megabyte instead of 913. So let's check. It's way lighter than this. Next question. Run the instance of this new and publish it on port 8383. So let's run a new. Let's just do a docker run and expose this thing to port 8383, and the port inside the container is 8080. That's what we're exposing to, 8383. And let's give the name. The name is web app color of the container, tagged with lights. It's running, and let's see, we have to test it somewhere here if the port is the host is exposed here. It actually is. So let's click here. It's running very well without any problem. I just access the link so we can see that I just access the root URL here. I can access another URL. Let's say /tests2. URL doesn't exist. It's a 404 page, so we can see it somewhere here normally. So if I check normally, I should be fine. We're fine, and congratulations, you're done successfully. So thanks for viewing, and see you in another exercise for another practice session where we'll be doing Docker and Kubernetes things. And don't forget to subscribe to get updates and support the channel, and see you on another video.